Hello, teacher. Now I started the presentation on Algorithm 2, the final project. Uh, the group is Eric and the Catherine. The objectives on the project are clear. First, to build a tool help is student search academic regulation quickly. Second, to apply concepts from algorithm tool, such as a hash table, string mesh, and the complexity analysis, KMP, and the other. Third is to improve efficiency compared to the original solution, both in speed and the memory. Fourth, to validate the system with the util tests, and finally, to create a modular program that it can be explained in the future. Problem with the original solution. The original solution had many problems. The search method has too simple. It returns articles if the half of words matched. They cause false results. Sometimes include wrong articles or missing the correct ones. Then it has the next normalization. So really like tests and the tests. Where are the difference? The search as linear scanning our article, which is low, and the memory usage has poor with redundant structures like listed tests, trees, and the duplicated data. Point purpose. Point purpose solution fix the problem. Use a hash set, the story common word, so can remove it quickly. Article is story. In a list here, she set the word for fast search. Carries are normalized. Common words are removed. For example, ed, para, these words. And the relevant article are chosen that contain at least half of specific words. Results are printed in the clear format. This making the system faster, lighter, and more accurate. Implement the tasks. The program is modular. The main class entering the point, the menu class handle user interaction in the console, the search engine class process and carries and the performance searches. The regular automation loader heads regular automation is file and creators article object. Article representation regulation. Article with a number, title, text, and the words. This separation makes the code easy to maintain and expand. Complexity analysis. Original. The search complex is a O-N multiply N. Because it scanned our articles and our query words after 6 weeks, implement the Knowledge spread. Is KMP as complex. How KMP this solution less and the profit now is ON mais N. Some medo. Because it processing the carry word a voice and repeat comparison, this make the search more efficient and scalable. In the project, every carry word is checked with a KMP inside the article text. Now I pass to Katerine continue.
Hello everyone, my name is Catherine and I'm going to continue our presentation. So I'm going to talk about testing. And well, we tested the system with a unit. So NP carries returns no result. Carries with only common words returns no results. Carries with existing words return relevant articles. Carries with no existing words return um, no results, and carries with multiple words written articles that contain at least half of them. We also tested the article class to check if word containment and output formatting work correctly, and these tests gave us confidence that the system worked as expected. Now talking about future improvements. Well, the system works well, but we can improve it in the future. One idea is to normalize accents characters. So, for example, thesis and thesis with accent are treated as the same. We could also build a grammatical or web interface to make the tool easier to use, and we could expand the inverted index to make search even faster. Now I'm going to present our live demo. So well, let's continue with our live demo. First, I'm going to run the application just to explain while I am showing the execution. So, well, first we have the menu of the program. It lets me load the regulation file, search articles, or exit. And this menu is controlled by the menu class that have the search case. And well, first I'm going to load the regulation file. I'm going to choose the regulation general. Let me code the absolute path. And well, when I choose a optional one, the program uses the regulation loader classes, and it reads the file line by line. And when it finds a line starting with ART, it creates an article object with the number, title, and text. So this way, all articles are stored in memory for searching. And then um, we are talking about the search query processing that is happening here. So first we have a list of common words. And when the regulation is loaded and someone wants to process a query, the first one is here. So this line takes the user's query, makes it lowercase, removes special characters, and splits into words. So this prepare the query for analysis. Then we remove the common words using a hash set. The hash set is here, that is here. So, so when these loops is going to throw each word. If the word is blank, we skip it. If the word is not in the set of the common words, we add it to the list of a specific word. And this is how we filter out words like the, la, and others. And well, then the program searches articles with this method. So the code checks each article, and for each specific word, it calls contains word KMP, which runs the new Morris Broad algorithm on the article's text. So the KMP loads a helper table called LPS to escape repeated comparisons, making the search efficient. And if the article contains at least half of the words, it is added to the results. And to finish, I'm going to show you a practice demo. So we have the regulation. Now I'm going to choose option number 2. And I'm going to try with any query, and we don't have article with query with anything. Now I'm going to try with only common words, and we don't have articles because they are common words and common words are ignored. Now I'm going to try with only one word, thesis, and we have all the articles that have the word thesis, and I think they are all the articles. And now I'm going to try with a sentence. So I'm going to put tribunal también this. So now we only have a article that have tribunal, examen, or thesis, and we need at least 2 of them. For example, the first one have thesis and have examen. The second one have thesis and have tribunal here. And we have only parts that have at least 2 of them. And now I'm going to run the unit test. The first one is for article test. So first we test contains words if it has the number, title, and text. And then we have text to string format, and we format the article with number of the article, title, and text. And the second one is about the search queries. So we have 6 test case. Oh, sorry. So the first one is about input query. We have the input query. We also have to remove common words. We have to test only common words. Test if specific words exist. Test words that do not exist. And test multiple words. And that's all about our live demo. And to finish, in conclusion, our solution corrected the flaws of the original design. At first, we used a hash set for word lookup, but in week 6, we implemented the KMP algorithmic that makes the search efficient with complexity O(n plus m). The system is modular, validated by tests, and shows how theoretical knowledge can be applied to solve practical problems. By considering future improvements such as access normalization and approximated matching, we demonstrate that the project is not only functional but also forward-looking, with potential to evolve into a more powerful and user-friendly tool. Thank you so much. That was our presentation.